Hello, everyone, and thank you so much for joining us for Moonbeam's workshop at EthIndia. Today, I'm very excited to talk to you about Moonbeam, about connected contracts, about the bounties, of course, and much more. So we'll start with a quick introduction to Moonbeam. I'll speak about connected contracts, what they are, why we're so excited about them, and why they're the main focus of this year's bounties. I'll go through a couple different demos. And of course, we'll wrap up by looking at all the bounties and not just looking at them, but showing you exactly how you can get started. There are a number of tutorials regarding and relating to connected contracts so that you can go from 0 to 100 really, really quickly, starting with your basic tutorials and then moving on to more advanced things. And I think that this will help you be well on your way to building and launching a connected contract on top of Moonbeam. So that's kind of the goal of today. And without further ado, we'll go ahead and jump right into it. And a quick introduction. My name is Kevin Nielsen, and I'm a developer relations engineer at Moonbeam. So before I jump into Moonbeam and connected contracts, it helps to understand a little bit of the why. Where are we coming from, and why are connected contracts so important? And in order to do that, it helps to understand why is the future multi-chain? And not just the future, but why is the present multi-chain as well? And so there are a number of reasons for this. One is that there are an increasing number of users in the Web3 space. There are an increasing number of demands that are placed on chains for block space. And with this, we see a rise of many different types of new chains. We see app chains, we see layer 2s. I've heard people mention layer 3s and layer 4s. There are game-related chains. There are chains that have a lot of demands or apps that have a lot of demands in and of themselves, and they can eventually evolve into their own type of chain or maybe take up a layer 2 or things like that. And so all of this is to say that the number of chains in the world is not decreasing and it's not staying static. It's rapidly increasing. And so when we think about the experience that users can have and will have, do we want something where users are hopping from chain to chain in kind of a discombobulated and disconnected experience? Or would we rather have an experience where users can interact with features and apps from many different chains, but instead have a home-based chain or have a comfortable experience where they can access this functionality and features from one place? We certainly believe in, and we certainly want to offer users a familiar and comfortable experience where they can access features across many different chains, all from Moonbeam. And so in this little diagram at the bottom, we say that as time marches on, there are an increasing number of chains, and not just proliferation of chains, but also a proliferation of tools that make it easier for you to launch your own chain. And part of that is from frameworks like Substrate, which make it very easy for you to launch a new blockchain in the Polkadot ecosystem. And with that, let's go ahead and jump to the next slide. Before we talk about where we're going, it helps to kind of think about where we've been. And with that, we kind of have two multi-chain approaches of yesterday, and that is throughout the Web3 space, there are really two here. One is a centralized deployment model. So you say to your users, here we are. Perhaps it's a new chain. Perhaps users are already familiar with it. But in any case, you're asking some users to bridge to this new chain, or you're asking them to acquire a token, perhaps on a centralized exchange or a decentralized exchange. You're asking them to set up shop, so to speak, on this new chain. And this does have an advantage or two. One is that when you're upgrading your protocol, you only have to upgrade it in one place. You kind of centralize a lot of activity on this one place. And so it has a few advantages, but it's not hard to see the disadvantages. You're segmenting your audience. There may be some users who don't feel comfortable bridging into it, or perhaps have the bulk of their activities taking place on another chain. And so you're limiting your market. And so the Web3 space kind of quickly realized that, okay, centralized deployment, that's one thing, but we really need to move on to something else. And that led to the multi-instance deployment. And the multi-instance deployment is easy to understand. It's kind of a copy-paste model where you take the exact same application and you deploy it to many different chains. This is allowing you to reach more users, presumably, and perhaps you can offer specific features on different chains. If they offer the ability for you to release a new type of feature, perhaps you can offer special features on a few of those chains. But again, it's not hard to see some disadvantages here. One is that you're fragmenting your users, you're fragmenting your liquidity, and you're dividing it up across, many, many different chains. Now, you may interact with this front-end dApp all from the same place. And then you go up to the upper right-hand corner, and then you can switch your network, and maybe you see, 5 or 6 or 7 or more different networks. But make no mistake, these networks, they don't know anything about each other. They're not helping each other. They're not mutually beneficial. They're just distinct, separate, different networks that know nothing about each other. And as such, your liquidity, your user base, all that is segmented and separated out across networks. But what if there was a different way? I'll explain the connected contracts approach in just a minute. But first, I'll introduce Polkadot and Moonbeam. So Polkadot is a LayerZero. Polkadot started being built around 2016. And it was at that time when the founding team took the approach that the future was going to be multi-chain. Now, this is a common belief, but back in 2016, it was a controversial take. And so the Polkadot founders knew that the future would be multi-chain, but so they decided to focus their efforts on how do we best support these specialized blockchains. And that led to Polkadot as a LayerZero, where Polkadot is a blockchain of blockchains. You're not going to deploy a dApp directly to Polkadot. You can't deploy a dApp directly to Polkadot. It does not have a smart contract execution layer. If you wanted to make your dApp your own blockchain and then launch it on Polkadot, you could do that. But the majority of dApps will more than likely, prefer to launch in a smart contract platform. And so Polkadot as a LayerZero provides the base layer, the infrastructure, including security, networking, and organizational infrastructure to allow for these layer 1 blockchains to run on top of it. And Moonbeam is a layer 1 blockchain running on top of Polkadot. The philosophy behind Polkadot is to not just have a bunch of independent, distinct chains not talking to one another, but instead to have a bunch of these layer 1 blockchains all talking to each other, all benefiting from the existence of each other. Meaning that each chain can specialize in something. So you may have one chain that specializes in privacy. You might have one that's a bridge hub. You might have one that's a connected contracts hub like Moonbeam. And so the idea is that all these layer 1 chains can talk to one another, and suppose you want to benefit from one of the features, right? Well, instead of having to move your funds over to another chain and then go ahead and take that action, you could be on the chain on which you started, and then you can send a request to that other chain, and you can take that specific action, all without ever leaving or having to bridge funds or change your network or anything like that. And so that's kind of the idea behind Polkadot. So where does Moonbeam and where do connected contracts fit in? Well, the idea behind Moonbeam and this connected contracts approach is that we want you to be able to access features, functionality, and assets across all and any and all different chains. That includes not just Polkadot, but that includes ecosystems outside of Polkadot. That includes Ethereum, Avalanche, Cosmos, and many others. I've only listed a few here on this slide as an example. But it's not just about bridging. It's not just about sending messages from chain to chain, but it's about being able to take advantage of a specific feature that may be available to you on another chain. And you can do this all for Moonbeam. And I'll show you exactly how you can do that in just a little bit. So a little bit more about how Moonbeam supports connected contracts and why it's a great place to launch a connected contract. For one, Moonbeam has this connectivity with a huge variety of general message passing protocols. We'll talk more about what that is in just a little bit. But general message passing protocols allow you to send a message from chain to chain. And when I say send a message, I mean you can literally say, hello other chain, and we will do a hello world example. But generally speaking, you're going to be calling a contract. And so you're going to be sending a message which has the contract's information that you want to interact with. It'll have a payload, so it'll have the exact function call data that you are providing. And it may provide other information such as a gas refund address or things like that. Next, Moonbeam is an ideal place to launch your connected contracts because it's so easy and convenient. This goes back to Moonbeam's launching a fully Ethereum compatible environment, not just providing an EVM and saying, okay, here you go, here's your EVM, but focusing on all of the tooling and infrastructure and all of the developer tools that you have come to know and love being an Ethereum builder. So that includes things like OpenZeppelin, Hardhat, Truffle, MetaMask, Remix. I can go on and on. All of these things, they work out of the box. It's not a fork. It's not some crazy complicated setup where you need to fork the repo and then change all these settings. All of these tools, they work out of the box with Moonbeam because Moonbeam is so Ethereum compatible. That's an important point to talk about because there's no learning curve. It's very easy to build on Moonbeam. And the third is that Moonbeam and Polkadot offer you a path to scaling. So where you may start as a dApp or a small smart contract, at some point you may want to grow into your own chain. And you can do that with Moonbeam and Polkadot. There's a path for you to go from a small smart contract to a large, perhaps independent chain, which is focused just on your application. There's a path for you to do that, which is very, very cool to see. So one key innovation to point out is general message passing. So I mentioned this a minute or two ago, but general message passing is the idea that you can send tokens or messages between different chains. You can send arbitrary bytes of data. And Polkadot has a built-in message passing system called XCM, or cross-consensus messaging. This allows you to send data between these different connected parachains or layer 1 blockchains that exist on Polkadot. And it's not just between Polkadot parachains. I mean, XCM is generally speaking focused on Polkadot, but it's meant to be abstract enough. It's meant to be compatible and general enough that it could be adopted by other blockchains. So that's kind of all I'll say about XCM. But we'll also focus on general message passing between Moonbeam and other ecosystems like Ethereum, Avalanche, and Cosmos. So let's go ahead and dive into that. So there are a couple different types of connected contracts that you may be interested in building. And the first one is one in which I will demonstrate in a demo in just a little bit. And that is a hub and spoke model. The idea here is that the brains of your smart contract, all of the complex execution logic that you need on chain, all of that exists on Moonbeam. And then you have satellite smart contracts deployed to other chains. And these satellite smart contracts, they'll handle more basic tasks, maybe depositing of assets or listening for messages from Moonbeam. And generally speaking, the hub at Moonbeam, the hub smart contract will contain all of the decision-making logic, and then those decisions will be propagated out to the satellite contracts deployed to the other chains. We'll take a look at a very practical and hands-on example of this with Prime Protocol. And the other example would be a point-to-point model. So this is where you don't have a hub you don't have a specific hub per se, but instead you have a point-to-point model where you have a message that's passed from chain to chain to chain, and the deployments are able to talk to one another, but you don't have this centralized decision-making place that's dispatching all. You don't have this one-to-many relationship. Instead, you have this one-to-one relationship. I do want to give an example of connected contracts before we go any further. And one example of connected contracts within Polkadot is Lido. Now, you may already be familiar with Lido's liquid staking on Ethereum. That product's been around for quite some time now, and it is nothing short of revolutionary, because typically, your staked ETH would be locked and inaccessible for an indeterminate amount of time, but Lido brings you liquidity, and they give you an asset that represents this staked ETH that you can now trade, put in DeFi. You can do just about anything you want with it. So Lido wanted to bring a similar product offering to Polkadot. But because there is no native smart contract layer for Polkadot, you can't deploy a smart contract directly on Polkadot. That's where Moonbeam comes in. And not just Moonbeam's EVM execution environment, but there are very specific XCM related features that Moonbeam has enabled, which allow this capability. And so I'll walk you through the flow of kind of how this works. Moonbeam has the ability to have DOT live on Moonbeam. So you can have the asset of the Polkadot relay chain, which is DOT. You can have that living on Moonbeam. And you can put it into DeFi and you can do various things with it. And that's enabled by XCM. So once you have this XC DOT, that's the name of the asset when it's on Moonbeam, you can then stake it in Lido's smart contract. And Lido's smart contract on Moonbeam will take that XC dot, it will move it back to the Polkadot relay chain via XCM, and then it will stake it to a validator. And all of this happens in a trustless manner, in an on-chain manner. There's no assumptions here. There's no off-chain interactions that are taking place. All this happens autonomously when you stake it. And it's very, very cool to see. And this is a key example of a cross-chain interaction where not just value is being transferred, but value is being transferred and then a remote action is taking place. This is actually kind of the first example of connected contracts on Moonbeam, and an early example. So for another example, this one is outside of the Polkadot ecosystem. It's launched on Moonbeam, but it is not focused just within Polkadot. So that is Prime Protocol. And Prime Protocol is a decentralized prime brokerage. A prime brokerage in traditional finance sense is typically caters to VIP clients of the bank. And the idea is that you have a variety of different assets that your prime broker has control of. And maybe you have stocks, you have bonds, and you have a variety of these financial instruments. And as a VIP client, you go to the bank and you say, hey, I'd like to take out a loan, maybe some cash, maybe some other assets or whatever. Let's say you want to take out a cash loan for simplicity. Well, the bank looks at all these different type of assets that you have and says, yeah, we're very comfortable in making this loan because we have control of these assets that you have. And when you think of lending and borrowing within crypto, typically the assets that you supply on collateral need to be supplied in the same place where you're taking the loan. So if you want to take out a loan on Moonbeam, typically you would need to deposit collateral to Moonbeam. So let's say you have some Ethereum and you'd like to use your Ethereum in order to take out a USDC loan on Moonbeam. So first step, you need to bridge your Ethereum to Moonbeam, and then you deposit it into a lending and borrowing protocol, and then you'd be able to get your USDC loan. But what if there was a better way to do this? What if you could access more assets across a variety of different chains? That's really what Prime Protocol is going for. And they do this with the hub and spoke model. So instead of bridging your funds from Ethereum to Moonbeam, you can keep your ETH on the native chain. You can keep it on Ethereum. And you can deposit it into this satellite smart contract of Prime Protocol. So essentially, you're just depositing it into a contract on Ethereum where Prime is listening and looking. And so Moonbeam is the operations hub of Prime Protocol. and it recognizes that you made a deposit on Ethereum. And so then it says, okay, you can take out a loan on Moonbeam now. And there are specific, parameters and specific parameters for risk management and liquidation and the sort. So let's suppose that I also want to deposit some collateral on Phantom. You can do that as well. And there are other networks as well. This is just for example purposes. So Prime Protocol will consider the collateral that you've deposited across Ethereum and Phantom. And then you can take out this loan. And again, any liquidation decisions or any sort of management decisions, all of that takes place on Moonbeam. So I think that's enough of a quick explanation. Why don't I go ahead and demo it? So to do that, go ahead and head to app.primeprotocol.xyz. And Prime Protocol is in testnet. So there may be bugs. I haven't experienced any just yet, but keep in mind it is a testnet. And here we have our network set to Moonbase. That's Moonbase Alpha, or the Moonbeam's testnet. So I have some testnet funds here. If you don't, you can just go to faucet or you can go to apps.moonbeam.network /Moonbase Alpha /faucet. You can just Google Moonbase Alpha faucet, and this will come right up. So you do need to have some Moonbase Alpha funds. I've also gone ahead before this workshop, and I've gone ahead and made sure that I have some testnet Phantom and some testnet Avalanche on the respective networks. And this is so I can deposit this sort of collateral and pay for the associated transaction fees. So what I'm going to be doing today is I've started with a fresh account. So all I've done is filled up my wallet with some funds, but I haven't done anything else. I have nothing borrowed. I have nothing deposited. And so we're all zeros here. So what I'd like to do is I'd like to deposit some Phantom and some Avalanche, and then I'll go ahead and take out a loan. So let's go ahead and do that. Let me deposit, let's say 3 or 4 Phantom. So I'm going to choose the network here. I'll be prompted to switch my network here in MetaMask. So I'll go ahead and switch. And I'm going to deposit less than the max because I want to keep some for fees and just as a precaution. So we'll deposit 3. It has a deposit value here. Keep in mind this is the testnet, so you can ignore the values here. I'll confirm the transaction in MetaMask. And while we're waiting, I'll do the same for Avalanche. So I'll go ahead and deposit some from the Avalanche testnet. I'll be prompted to switch networks in MetaMask. And again, I'm not going to deposit the full amount. I'll just choose 1 in this case. And we'll confirm the transaction in MetaMask. To check on the status of our transaction, we can go ahead and click here. And let me just talk a little bit about what's going on. We made these deposits, again, on the satellite chains, but now there's messages that are being sent between the chains, so between Phantom and Moonbeam and Avalanche, letting the home base chain, so letting Moonbase Alpha know, letting the Prime Protocol smart contract, letting it know that I've deposited these funds on the remote chains. And so then Prime will allow me to take out a loan. And I'll just walk through a little bit about what's going on here. So we're sending the message from Avalanche to Moonbase Alpha. The gas needs to be paid for, meaning that when we make this deposit on Avalanche, we need to send along enough funds in order for this message to be sent to Moonbase Alpha. And when we say the message to be sent, that means that there's a contract interaction that's happening with Prime Protocol. And so that's a contract interaction that's taking place on Moonbase Alpha, and that does need to be paid for. And the same thing with the Phantom interaction. So let's head here. Let's see how we're doing here. Cool. So it is a 4-step process, so to speak. It's broken down into 4 different categories here. You have the contract call on the origin chain. So that would be Phantom in this case. You have the gas being paid. So again, that's on Phantom, you're paying for the contract to be executed on Moonbase Alpha. You then have a call approval, and this is the Axelar network handling behind the scenes, making sure that not just the gas is paid, but that this is an authentic, legitimate contract call, and it's authorized and everything else checks out. And finally is execution. So the contract interaction taking place on Moonbase Alpha. And you can see here the transaction on the origin chain. We can click here and see it on Phantom. And if you want to see the contract interaction on the destination chain, you can click here on transaction hash here. Cool. Now, if I go back to Prime Protocol, I should see my balances updated. So again, these amounts, they're testnet, so they may not be perfectly correlated to anything, but you can see that I have a wallet balance here left over, and I have a deposited amount deposited. So I've deposited 3 Phantom and 1 Avalanche token. Now, based on this, I can borrow a certain amount, and Prime has computed exactly what I can borrow. And if I'd like to borrow, I just go here and press borrow. And the network that I'm going to borrow on is going to be Moonbase Alpha. So I'll go ahead and switch networks, and I'll enter in some amount. It gives me the max borrow amount. Let's choose roughly half that. So we'll say something like 446. And we'll go ahead and press next. And one quick clarification, USP is just a testnet stablecoin for US Prime Protocol or something like that. It's a stablecoin that represents the US dollar. So we'll go ahead and press take loan. And we'll go ahead and confirm this. And some other things you might want to explore here. We're just interacting with a couple different networks here in this example, but you can actually deposit assets across a variety of different networks. And there's also a faucet here where you can mint these testnet tokens. So if you want to go and mint a bunch of USDC and then deposit that, you can do that here on Prime. So let's see how we're doing here. This should be confirmed in just a second or two. Yep, and it was just completed. So I've now borrowed $4.46. And you can see here I have a health ratio. And if this health ratio drops, then you have a problem. I believe something around 100% or 105% is kind of the minimum that you can be at. Let's see what happens if I press next. Cool. Yeah. So it will predict your health ratio. So yeah, about 103 is kind of the bottom. And it'll tell you that before you confirm your loan. If I want to repay my loan, I can go ahead and press repay. And yeah, there's a lot more that you can explore here. This was just a quick introduction, introducing you to a connected contract. I'm going to head back here, and I just kind of want to explain a little bit more of the why, right? Why is this connected contracts approach so important and valuable? And at the end of the day, it's about providing better user experiences. Nobody wants an experience where they have to bridge from chain to chain to chain in this kind of discombobulated manner with tons of different MetaMask pop-ups and kind of confusion and you know the experience where you don't have the native token on the chain on which you're bridging to, and then you have to figure out how to get it, and it can be stressful and confusing. So it's about solving these fragmentation issues that are inherent with having a multi-instance approach. And not only that, but being able to give access to users to access more features and more functionality, and be able to do it all from a place like Moonbeam. In addition to that, it improves the end user experience because it hides infrastructural complexity. when we go back to Prime Protocol here, when we were depositing these assets and things like that, we saw a convenient user interface where we can check the status of transactions. We don't need to necessarily go and look on Phantom Scan or look on Axelar Scan. We can see it all from here. Users don't need to bridge funds from Phantom to Moonbase Alpha or from Avalanche to Moonbase Alpha. They can access these funds that are on these different chains, all without ever having to bridge. That's very cool and very powerful. And of course, it speaks to another major benefit, which is you don't have these bridge honeypots. If users aren't bridging funds, then you don't have one contract, which is suddenly a target for hackers. With DeFi, you have many hundreds or thousands of applications. And so if they all take up a connected contracts approach, well, now you have many hundreds or thousands of contracts or satellite contracts. And so these are less of a target for hackers. And for the next demo, we can go ahead and head to Moonbeam. Oops, sorry about that. I'll go ahead and open it up here. So it's moonbeam-multichain-demo.netlify.app. And I'll make sure that we have a publicly accessible slides with clickable links and everything like that, so that you don't have to type in the links manually. Okay, so here we'll be demonstrating sending a message cross-chain and kind of walking through what this would look like. This is a quick demo. We'll go ahead and connect MetaMask, and I'm connected to Moonbase Alpha. And let's talk about the message that I want to send. Let's say that I want to say EthIndia 2022, and we're going to be sending this message from Moonbase Alpha to another chain. Let's start with via Axelar. So Axelar is the GMP protocol, or General Message Passing Protocol, that we're using to deliver this message. And let's send it to the Avalanche testnet. So here I'll go ahead and press submit. And my message will be encoded in the payload of the cross-chain message that we're sending. And you'll notice here that we're paying a little bit more than usual here for a transaction because we have to have this contract interaction taking place on the destination chain. And so we need to pay for that along with the transaction that we're making here. So that's why the amount that you're paying may seem slightly high. So go ahead and press confirm. And as per usual, we can take this transaction hash and we can look it up in Axelar Scan. So if I paste that in here, it will be recognized probably just as soon as the transaction is confirmed on Moonbase Alpha. So that may just take a couple seconds or two. I think it was just sent. So let's go ahead and refresh. Here we go. It just popped up. Cool. So we can see exactly what's going on here. And once this message is sent, we'll be able to read the exact message. So again, this is just a simple example. We're sending a message here. Hello world. What's so cool about that? Well, I'll tell you. What's so cool about that is that you don't always have to send just a hello world message. You can send contract bytes, or you can send a payload for calling a smart contract. So what does this mean? This means that you could make a swap on a remote chain. This means that you could interact with an NFT. You could equip your NFT. You could buy something for it. You could make any kind of swap. You could buy a token, buy an NFT. You can do all of this, and all of that can be directed by a chain such as Moonbeam. This is very, very cool, and it's we'll check in on the status on this in just a second. But this is cool because it's virtually any contract interaction. It's extremely powerful. Once you try it out for yourself and see how it works, it's really, really cool. So we see here that the status was successful. Let's actually read the read the contents, of the message. Obviously we know what it is, but let's just read it here using this. So I'm going to change here to Avalanche Testnet, and we can see here that the message here is EthIndia 2022. And if we want to see the message on the destination chain, so I'm going to head back here to Axelar scan. I'm going to click on the transaction hash on the destination chain. And if I go down here, I can see all the data for the contract interaction, all the payload and everything like that. Let's view the input as another format, and we can see here EthIndia 2022. We can see the origin chain. We can also see the contract address that it's interacting with. So that was just a very simple demonstration. You don't have to use Axelar. You could use Hyperlane for this. And this is just for the demo. There are other GMP protocols, Wormhole, LayerZero. There are many options that you have. And we'll talk more about each specific GMP protocol. But here, this was just a quick demo, and I do recommend that you try it out. And after you try this out, you can actually go and recreate this yourself manually in Remix with a couple of different Solidity smart contracts. So if you want a bit more of a hands-on way to do this, there's a blog post detailing exactly how you can do that. And that blog post I'll show in about 3 or 4 slides. So let me just skip ahead right there and show you the exact blog post. So that'd be this one here, the Axelar one. And if you go ahead and open it up, you'll see here the exact function, and you'll see exactly how you can create this contract in Remix. You're going to create a simple general message contract. You're going to select the right amount of tokens to send along to pay for gas, and you'll do all that. It's very, very fun. So I highly recommend checking it out. This will give you a great understanding of how this test app is working. And once you do that, then you can move on to more advanced examples. Okay, so back to the bounties. Let's talk bounties. The first and the major bounty is to build a connected contract. This is very open-ended, and it's a fantastic and very large prize amount bounty. So your challenge here is to build a connected contract with Moonbeam and any GMP protocol. You can use Axelar, you can use Wormhole, LayerZero, you can use Hyperlane, and you do have to have a contract deployed to Moonbeam. So the exact logic, it doesn't have to be a hub spoke model. You can have the contract logic be whatever you'd like, but you do need to have something deployed to Moonbeam. And so yeah, the exact requirements are very open-ended here. And if you're looking for inspiration, or you're looking for what to build, right? A great example is to kind of look at what's been successful in DeFi, what's been successful in Web3 in general for single chain deployments, right? And then maybe think about how you could build a multi-chain or a connected contract approach for this particular example. So if there's an NFT marketplace that you love and you've been thinking of building, well, what about building a connected contract NFT marketplace? Maybe one on Moonbeam where you can access NFTs on Ethereum, on Avalanche, on Phantom. And maybe you can make purchases and enact actions to take place. Maybe create listings, create sales, all of this. You can enact all of this to take place directly from Moonbeam. That would be very, very cool. And I'd love to see that get built. This is not a prescription. We're not looking for a specific, NFT marketplace. I just wanted to throw out an example or two in order to kind of get you thinking about what you might want to build. So let's go ahead and move on to bounty number 2. Bounty number 2 is a bit smaller, but it's a bit easier. And so this is also open-ended as well. And the general idea here is to use any of Moonbeam's Solidity interfaces. We call these precompiles. And precompiles are Solidity interfaces which expose functionality that could be unique and specific, which you may not otherwise be able to access. So This could be substrate native functionality or functionality that exists within Polkadot, such as on-chain governance. You can access this via a Solidity smart contract or an interface called democracy.sol. That's just one example. Moonbeam also has native staking. You can access this via a staking precompile. We also have a batch precompile where you can take multiple different EVM transactions that you'd make, and then you can batch it up in a couple different smart ways. So you can say, let's say you have 3 different calls. You can say do all or nothing. You could say do as many as you can until one fails and then stop. Or you could say just try to do as many as you can. So if one fails, skip it, move on, keep trying for the next one. There's also on-chain randomness, which is, of course, very useful for gaming. There's cross-chain capability via XCM and Polkadot. We have lots of content on XCM. We have entire workshops dedicated to cross-chain transfers and cross-chain interactions between Moonbeam and other parachains and the relay chain in Polkadot. So there's a lot there. But the beauty of this bounty is that, it's not prescriptive. You can do just about anything that you'd like. I named here, what did I name? 4 or 5 precompiles. There's probably a dozen or more different precompiles that Moonbeam has. And all of these enable novel features, and they enable you to build really, really cool things. So I highly recommend that you check this out. And again, you can stack these bounties. So maybe you're going for a couple other bounties and you say, hey, I'd like to stack this one on top. That is perfectly fine. Your project, sorry about that. Your project will be eligible for this bounty if it utilizes any method of any precompile, any Moonbeam precompile, in a non-trivial way. So that's just to say that, if you're in a non-trivial way, meaning don't put this buried away under 6 setting levels, meaning you have to go to your settings and then find a hidden menu and then we expose a little feature there. It should be somewhat substantial to your application. And we have a full list here of Moonbeam's precompiles. If I click on this, you'll see here that in each of these we walk through exactly how it works. So for the batch precompile, we show you how you can access it, the address here at which you can access it. We show you all the different methods. We show you all the parameters. And then we walk you through step by step exactly how you can interact with it with an example contract, and how that example contract would then interact with the precompile. I'm more than happy to provide some examples and suggestions about what you might build with these precompiles. So reach out to us in Moonbeam's Discord. That's discord.gg/Moonbeam. There's a builders channel. I'm more than happy to discuss what I'd love to see built or anything like that. Again, not prescriptive, just to give you an example, right? You're saying, hey, what can I build? What should I build? We got tons of ideas. This author mapping precompile here, this is very valuable for collators. Collators are block producers on Moonbeam. So you could build a utility that makes it easier for collators to set their author mapping and change various settings there. And a convenient GUI would be very welcome. So there's much more here. Just to be cautious of time, I do want to keep moving right along. And as I promised at the beginning, this workshop is meant to point you in the right direction. Where do I go next, right? Okay, I know a little bit about connected contracts, right? But I'm not sure what I want to build or how I want to build it. We'll show you exactly where to go from here. So with these GMP protocols, we have tons of different tutorials. And Jeremy from the developer relations team has built these fantastically thorough but easy to understand blog posts which take you through step by step of sending a message, interacting with each of these GMP protocols, and all of these are fantastic. So for each of these, if you're saying, hey, I don't know, should I use Axelar, should I use Hyperlane, LayerZero, or Wormhole? Well, check out all of them. Or, just pick one, try it out, see how you like it. Yeah, we already went through this one, but let's check out the Hyperlane one. You can see here all these have helppful diagrams. They have code snippets. They have sometimes pre-configured remix links, so that you can, here we go, you can open it up directly from this remix link where the code is already pre-filled. All of this is extremely, extremely helpful. So LayerZero as well. Excuse me. And Wormhole, of course. So these blog posts are a great place to get started. But then where do you go from there? Well, we have more specific advice and documentation links to each of these. So all these GMP protocols have extensive documentation. They have code examples. They have the contract addresses. They have the assets that they support for cross-chain transfers, the chains that they support. All of this is very, very helpful. And we've tried to cut out some of the work for you by providing you these links all in one place and saying, okay, where do I go for my sending a message? Where do I go for my example dApps? Well, if you click here, Axelar has a couple different 5-minute starter examples. What about setting up a local environment? There are videos, there are tutorial links, and much more. Contracts is a particularly a big one, and I think I duplicated a link here. So let me go ahead and find that. If I head here to, I think it's the build one. Here you go, contract addresses. So I'll go ahead and update this in the presentation. Contract addresses, both for mainnet and testnet. You'll see some of the chains supported are a little bit different between the testnet and the mainnet. As you might expect, there are more on the testnet. These are not necessarily the same addresses across mainnet and testnet, so just make sure that you double check that. So I'll go ahead and link that here in the contract section, and we have the same for the other GMP protocols as well. So for sending a message with Hyperlane, there's a quick start tutorial. All of these, as you can imagine, all of these GMP protocols, conceptually and philosophically, they're similar. There are quirks, there are unique features. Just as a developer, you might prefer one framework over the other. You'll figure out which ones that you like and you're comfortable with, and they're all phenomenal options. And Moonbeam's goal is to provide you all of these options. We want to integrate with as many different GMP protocols as possible, and then let you pick which one you'd like to use. Perhaps you choose multiple ones. For a hackathon, you're probably going to go with just one, but for a production grade deployment, you might have a redundancy or a backup in place. And it's a lot of fun reading about how all these different GMP protocols work and the different ways in which they're implemented. So that's Hyperlane. We have example dApps here. We, meaning Hyperlane. I'm just having, we've linked to Hyperlane's docs to clarify. And of course the contract addresses. So very, very key. Then for LayerZero, we have sending a message with LayerZero. And you'll see that these are looking quite familiar, right? Of course, you have a destination chain ID. You have the address of the contract that you want to interact with, the payload, the refund address, and perhaps some more data. So all of these are similar. The parameters might be slightly different. The exact way in which you interact with each one can be slightly different. But again, the philosophy, the intuition behind them is very similar and familiar. Of course, we have the contracts here, very important. And wow, this is a huge list. And of course, these docs, they're updated all the time because the list of chains that you can interact with, it's growing all the time. The last time I was here, I think they were up to Clayton, I think. I don't think Metis or Intane was listed on this before. So very, very interesting. And of course, another thing to keep in mind here, chain ID, this is important. This is not the same chain ID in which you see on chainlist.org. So make sure that you check this. Make sure that you have the right chain ID that you want to interact with and send the message to. It's just important to know this. Once you know that, very easy to adjust as you go. And Wormhole. Sending a message, we have here. We have, Wormhole has a whole book, actually, a digital book for building cross-chain dApps, or as they call XDApps. I highly recommend checking this out. It's very cool and readable and divided up into these different sections, which is quite nice, and goes into some of the architecture details. So if you want to think about, how are you going to set up your cross-chain dApp? What's the architecture that you should think about? What are the design considerations, right? Some kind of higher level stuff as well as very low level stuff, of course, as well. But it's very cool to see this whole book that Wormhole has put together. And of course, you need to have the contract addresses, and those are available here. I like here that they've indicated Wormhole chain ID to make it clear that this is not the chain ID on chainlist.org, but a specific chain ID. And this is different from LayerZero. It's different from each GMP protocol, so it's just something to make sure that you're aware of. And I think that brings us to the end of this workshop and presentation. So let's just do a quick recap. We started with an introduction to connected contracts, Moonbeam, and Polkadot. Then we went to a quick demo of Prime Protocol. We went into a demo of sending a message cross-chain using Axelar and Hyperlane. We went through the bounties, and then we showed you, we kind of demonstrated how to get started, right? What are the examples? What are the tutorials that you should be looking at? And then in terms of where to go from here, I highly recommend that you check out, the links that were in the presentation. I'll make sure that the presentation is linked below. And then where do you get help? And you get help on Moonbeam's Discord. We're checking it all the time. We have just about 24/7 coverage, and we can't wait to see what you build. So thank you so much for participating in EthIndia. Thank you for considering Moonbeam's bounties, and we are here for you. We are here to help. Whether it's a question about Moonbeam, about connected contracts, anything at all. If you have a Solidity Smart Contract question, we can help you out as well. So thank you so much, and I can't wait to see what you built. And congratulations, and good luck with the building and the hacking. Thank you so much, and I'll talk to you soon.